domain and range. So let's think about domain in words and range. What kind of numbers could the domain be? What kind of numbers could the range be? Let's pick some variables first. X and Y are a nice choice. Alright, what kind of numbers can X and Y be? Well, I've got, thinking about my X coordinates, the lowest one is 1. The highest one is 7. So X goes from 1 to 7. The Y values go from -3 all the way up to 3. So that's going to be helpful when we're determining domain and range. So in words, we're going to write all real values between 1 inclusive and 7 inclusive. Okay? All real numbers between 1 inclusive and 7 inclusive. Okay, and then the range, again, that went from -3 inclusive to 3 inclusive. So we write that down. All real numbers from -3 inclusive to 3 inclusive. Alright, we got the words down. Now to number line. So we're just going to draw these in. Draw a number line going from 1 to 7. So here's 0, 1, 2, 3, 4, 5, 6, 7. I want it to include 1. So I put a closed dot on 1. I want it to include 7. So closed dot on 7. Draw a line between. And then a number line for the range. Want it to go from -3 to 3. So -3, -2, -1, 0, 1, 2, 3. Okay, include -3, include 3, draw a line between. If you need to pause at any moment during this to catch up, that's fine. Interval notation. The lowest value is 1. The highest value is 7. I want it to include 1, so I put a square bracket. Same thing for 7. Over here, I want it to go from -3 to 3. Include -3. Also include 3. And lastly, set notation. Remember, set notation, we do the variable first, such that any restrictions on that variable, and then the class of number that it belongs to. So in our case, again, X represents the domain, or the values for the domain. So we write X such that it has to be bigger than or equal to 1, and less than or equal to 7. And its class is it's a real number. So X is an element of real numbers. Then we go over here to range. This is represented by the variable Y, such that Y is greater than or equal to -3 and less than or equal to 3. Y is a real number. There we go. I'll leave that there for a second for you to copy. If you need to pause it, that's fine. Alright. I want you to try this last one on your own. Okay? You'll notice in your paper here that we've got arrows on the end here. They're not on my diagram, but they're on yours. We've got arrows on each end of this line here, indicating that this line isn't only restricted to this window. It goes forever in this direction, and it goes forever in this direction. Just give this a stab. Try to think about what the domain and range would be of a line that goes forever to the right, forever to the left, forever up, forever down. Hopefully you were able to crack through some of that. As I mentioned, the line goes forever to the left and forever to the right. So when I'm thinking about the domain of that line, it's going to include pretty much every number known to man. Okay? So we say for the domain, we say all real numbers. That's an easy one. All right? There's no restrictions. There's nothing that x cannot be. Assuming I define that axis as x and that axis as y. There's nothing that x cannot be, right? I can keep going to the left forever and ever and ever and ever, and I will always find x values. And I can keep going to the right forever and ever and ever, and I will always find x values. So it's all real numbers. Same thing with the range. I could go up and up and up and up, and I would keep finding that line, and I could keep finding points for the y values. Same thing if I went down. Okay, so the range is also all real numbers. Number line. How do you show every conceivable number on a number line? Well, it's not hard actually. You just draw any number line. I'll just make one going from -2 to 2. And then I'm going to do this. I'm going to draw a line on top of that. I'm going to make that line go forever that direction and forever that direction. There we go. That's every conceivable number on a number line. It means it never ends if I go to the right, and it never ends if I go to the left. Basically, it's the exact same thing for range. In fact, I'm just going to copy and paste that. Excuse me. I'm going to take this guy. Oh, maybe it's not going to let me drag it. No, it's not going to let me. Okay, I'm going to draw it in. So I draw any number line, really. We'll go from -3 this time. And I want to include all the numbers. So I just draw one big line, arrow going to the right, arrow going to the left. Interval notation. Well, this is the one where I write the smallest number, comma, the largest number. What's the smallest number here for the domain? Well, there is none really, because I could just keep going further and further and further to the left. So technically, the smallest, if you want to even call it that you can get is -infinity. The largest, therefore, would be +infinity. Now, what kind of brackets do I write around that? Do I write square brackets, or do I write round brackets? Well, let me ask you, can you ever actually get to infinity? Can you ever actually count that high? No, because the moment you say, I have reached infinity, someone just comes along and says, +1. Okay? They found a number bigger than yours. So because you can never actually get to infinity, we always use round brackets on infinity. Always round brackets on infinity. Okay, same thing with range. We go from -infinity to +infinity. Because we can't actually get there, we put a round bracket on each. Set notation, you're going to be relieved by this. It's pretty simple when you have an infinite set. Right? Like we did before, we say, okay, Our domain is represented by the variable x, such that, and you may be tempted to put x is greater than negative infinity and less than infinity. X is a real number. And you'd kind of be right, except that this portion is unnecessary. Because this right here, x is a real number, communicates everything that we want to say about x. If I don't put any restrictions on x, if I don't restrict it to any range of values, and if all I say is the domain is x such that x is an element of real numbers, this just means every single conceivable value known to man in the set of real numbers. And that's all we need to say. Same thing with range. Our set is represented by y such that y is an element of real numbers. We don't even need the inequality in there.